In this video, we will learn how to determine convexity, concavity of a function and how to determine inflection point of a function using cost function as an example. Question is, given cost function is c is equal to 10 plus 16x minus 18x cube. C is the cost, total cost, x denotes the units of output. We have to determine whether this cost function is convex or concave at an output level of 2, and second part is when output level is 5, that means when x is equal to 5. Second question is find the inflection point of the cost function. Okay, now what is when a function is said to be concave? Simple. If the second derivative of a given point is negative, second derivative at a given point is negative, we say the function is concave. I will explain it on the graph also. Okay, so bear with me. Also, we have convex. Okay, a function is said to be convex if second derivative at a given point is positive. Okay, also third is the inflection point. What is inflection point? Let me denote it by IP. Inflection point, to save the space here. Inflection point is a point where graph changes. Okay, where graph changes, it is convexity or concavity, changes from convex to concave or vice versa. Okay, so graphically what is meant by this, I will also explain it. Okay, if the second derivative of a given function is positive on the graph, it means, okay, if we draw a tangent, and let me draw it here to make it sense. Let us say it is a graph, and if we have this kind of function, okay, if I draw a tangent to this function at a given point, and if this tangent line is above the, you know, curve, above the cost function here, we say this function is concave. Okay, and I will explain it mathematically, rather what we are supposed to find I will explain. Second is, if we have what we call, let us see, this is convex. Okay, a convex function is at a given point. Okay, and if we draw a tangent to this curve, and if the tangent line lies below the cost function or below the given function, we say the function is convex. Okay, and third is inflection point. Inflection point is a point where, and let me draw, okay, so let's draw this kind of graph. Inflection point is a point where the function changes its concavity or convexity. If it is convex here, at this point, from this point it changes to concave, or if it is concave here, and from this point it changes to convex. Okay, inflection point is a point where the graph changes from convex to concave or vice versa. Simple thing. Now let's come to the question, and I will try to draw the graph. So first, okay, so first question is whether the cost function is convex or concave. Okay, so let's write the cost function, that is c is equal to 10 plus 16x minus 18x, actually it is 18x square here, square, and I also forgot to write the next term, that is 2 x cube. Okay, here it is 2x cube. Sorry for this mistake. Okay, given this cost function, to find out whether the whether a function is concave or convex at a given point, first we need to find out the first derivative. First derivative of cost function, we know it is the marginal cost, and it is being given by the first derivative of total cost function, that means dc upon dx. Okay, if we take first derivative of this cost function, what will we get? Derivative of a constant is 0, derivative of x is here 1, so we are left with 16, minus a derivative of x square will be 2x, so 2 into 18 is 36 x, plus derivative of x cube is 3 will become coefficient, 3 2s are 6, and exponent is subtracted by 1, so we will get 6 x square. Okay, so this is our first derivative, but we are interested in second derivative, and let me write it here. This is our first derivative. Now second derivative of the cost function is simply the slope of the marginal cost, and let me write it here, slope of marginal cost, and it is being given by the second derivative of the cost function, that means d square c upon dx square. If I take the second derivative of this cost function, we will get the slope of the marginal cost. So this is first derivative. Second derivative will be the slope of the first derivative. So derivative of 16 is 1. It is 0 because it is constant. Derivative of x is here 1. So we are left with minus 36, plus derivative of x square is 2 becomes coefficient, 2 6s are 12x. So this is the second derivative, or rather this is second derivative. Okay, now to see whether a function is convex or concave, we need to test that very point at the second derivative. Okay, so this is our second derivative. So the second derivative is this d square c upon dx square. When we evaluate it at the given point when x is equal to 2, so let us see what happens. Simply we plug x is equal to 2 into the second derivative function, where we have minus 36 plus 12 into 2, that is minus 36 plus 24. Obviously it will come out to be a negative number. Okay, so so this is minus 12, which is negative. Okay, which is negative. So we have seen at x is equal to 2, the function is concave. Why? Because the second derivative at x is equal to 2 is negative. Okay, so first point is actually the denotes the point where the function is concave. Similarly, we can find out for the second when, and let me write it here, when x is equal to 2. Okay, this was a part. Then b part is when x is equal to 5. I will also draw the graph to make it more useful. So when x is equal to 2, we check it at the second derivative, that means d square c upon dx square when x is equal to 5. Simply plug x is equal to 5 into the second derivative function. So we have minus 36 plus 12 in place of x, we have 5. So this is minus 36 plus 12 5s are 60. So this will come out to be Danishat 4. So it will come out to be plus 24. Since at second derivative the function is positive, okay, when x is equal to 5, the second derivative is positive, we say when x is equal to 5 the function is convex. Okay, now second question is find the inflection point. Okay, inflection point, or at inflection point second derivative will be either 0 or undefined. Okay, and let me write it here. At inflection point second derivative will be 0 or undefined. Okay, to find out the inflection point, we simply equate the second derivative with 0. Okay, so we, to find the inflection point, we equate the second derivative, that is, we are not supposed to find the partials here, d square c upon dx square, and we set it equal to 0, which implies minus 36 plus 12 is equal to 0. Rather, it is 12x. 12x is equal to 0, so we have 12x is equal to 36, which gives us x will be equal to 3. Okay, if we divide both sides by 12 here, we will get 3. So when x is equal to 3, at x is equal to 3, the function changes its concavity from being concave to convex, or from being convex to concave. Okay, so let us draw all these things on one graph, and let me rub this out. Okay, so let me draw the graph here. We have output on this side and cost function on this side. Okay, we have seen when x is equal to 2, the function was sorry, the function was negative and it was concave. Okay, here it is concave, so our function will look like this. So this will be the cost function. Okay, at x is equal to 2, let us say this is point where x is equal to 2. I have told you, when a function is concave at a point, and if we draw the tangent from that very point, the tangent line will lie above the function, and here you can see. And second was convex. Okay, so when x is equal to 5, let us say when x is equal to 5, and if we draw the tangent at that very point, the tangent line will lie below the cost curve, and here we can see the function is, sorry, the tangent is below the cost curve. So this denotes the concave, sorry, concave. This is our convex, and the point where the function changes from concave to convex here, or vice versa, it is a point of 3. Okay, so when x is equal to 3, the function changes its concavity. Okay, so this is our inflection point. Inflection point. Okay, at concave second derivative. Okay, let us denote it by d square c upon dx square. It should be negative. At convex, d square c upon dx square, it should be positive. And at inflection point, d square c upon d x square is either equal to 0 or undefined. Okay, I hope I make myself clear in this video. Thank you.